Imagine it's May 1st, 1957. You pick up the New York Times, flip through the pages, and come across a headline that stops you in your tracks. Physicist Creates Universe in a Test Tube, it reads. You pause, trying to wrap your mind around this idea, and for a brief moment you wonder, what could this possibly mean? Could science actually create a universe in a test tube? The 1950s were a time of immense curiosity and rapid progress. The space race was just beginning to take shape. Science fiction was captivating imaginations across the globe, and groundbreaking experiments were reshaping how we understood the world and the cosmos beyond it. It was in this atmosphere that physicist Winston Bostick conducted experiments that bridged the gap between the Earth and the stars. At the heart of his groundbreaking work was the concept of plasmoids, tiny self-organized balls of plasma. These fascinating structures offered a glimpse into phenomena that might explain some of the greatest mysteries of galaxies and the universe itself. And with the invention of the plasma gun and his experiments with magnetic fields, Bostick didn't just study plasma, he redefined our understanding of it. His paper, Experimental Study of Plasmoids, was published in the prestigious journal Physical Review and made waves, not only within the scientific community, but also far beyond. That New York Times headline wasn't just hyperbole. It hinted at a revolution in how we think about magnetic fields, plasma, and the very structure of the universe. Bostick's work caught the attention of the military-industrial complex, the very system President Eisenhower would caution against just a few years later. Back in 1957, humanity was only just beginning to venture beyond Earth. Sputnik hadn't even launched yet, and our understanding of the universe was still in its infancy. In this video, we'll briefly explore the fascinating experiments that put Winston Bostick on the map, the discoveries that hinted at universal truths, and the lasting impact of his work on both science and technology. Now imagine stepping into Winston Bostick's lab at the University of California Radiation Laboratory in Livermore in the mid-1950s. It's a world of wires, magnetic coils, vacuum chambers, and the centerpiece of it all, a device that sounds like something out of a science fiction book, the plasma gun. This wasn't a weapon in the traditional sense, but it was revolutionary. By firing streams of plasma across magnetic fields, Bostick created something extraordinary: plasmoids. So what exactly are plasmoids? Well, they're self-contained magnetic structures made of plasma, essentially ionized gas with its own electromagnetic field. Think of them as tiny spinning vortices of energy, capable of holding their shape and interacting with magnetic fields in fascinating ways. Bostick wasn't just making pretty shapes in the lab, though. These plasmoids hinted at the behavior of much larger phenomena, like the structure of galaxies or the swirling magnetic fields of the sun. Using his plasma gun, Bostick fired streams of ionized gas into a vacuum chamber, directing them through powerful magnetic fields. What he observed was groundbreaking. The plasma would form the stable, toroidal shapes like tiny glowing donuts in space. These weren't just fleeting events either. They were dynamic and enduring, existing long enough even for Bostick to study their behavior. To capture these fleeting moments, Bostick used advanced technologies like probe traces and Kerr cell photography. Though he couldn't directly see the plasma, the changes in the surrounding magnetic fields revealed their structure and motion, providing a window into the dynamic, unseen world. The steep leading edges of the signals, the oscillations, and the intricate patterns all painted a picture of how these plasmoids interacted with their environment. Through this clever setup, he could observe how magnetic fields were dragged and twisted by plasma, a finding that reshaped our understanding of this cosmic phenomena. They suggested that the same fundamental forces governing tiny plasmoids might also shape the cosmos, from the swirling arms of galaxies to the behavior of solar flares. These findings weren't just scientific curiosities. They hinted at universal patterns, bridging the smallest scales in a lab with the largest structures in the universe. And for those with a speculative streak, it raised even bigger questions. Could plasmoids help explain the origin of the universe? Might they hold the secrets about energy, matter, or even life itself? Let's get back to the New York Times article. Why did they call Bostick's experiments the creation of a universe in a test tube? The answer lies in the incredible behavior of the plasmoids he observed in his lab. He found that they weren't just random shapes. Sometimes they avoided each other like magnets repelling. Other times they interacted and merged, forming larger, more intricate shapes. Often, they spiraled together in patterns that mirrored the barred spiral galaxies scattered across the universe. A universe in a test tube. To the scientists observing this, it wasn't just an experiment. It was a glimpse at a universal force at play, scaled down to the size of a vacuum chamber. The way these plasmoids moved, interacted, and self-organized felt as though Bostick had captured the essence of cosmic creation and brought it into his lab. Whether we're looking at plasmoids forming in a lab or a barred spiral galaxy spinning in space, one thing is certain. The universe operates on patterns and forces we are only just beginning to understand. Winston Bostick's work gave us a glimpse into these mysteries, showing us that the smallest sparks of plasma can reveal truths about the largest structures in the cosmos. His experiments weren't just revolutionary for their time. They remain a testament to the power of curiosity and the boundless potential of discovery. Be sure to keep an eye out for an upcoming live session where we'll explore Bostick's full paper and immerse ourselves in the mysteries and science of plasma and plasmoids. For now, let's take a moment to appreciate how Winston Bostick's experiments changed how we see the universe. If you've enjoyed this video, you know what to do to help other curious minds like yourself find it. Until next time, may your day be filled with learning and curiosity. Thank you for watching, and take care.